Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 11 of a unit system of particles and rotational motion. Let's begin with today's class. In this session we are going to discuss about the additional questions on the topic rotational motion. So be ready with your pen and paper. You are not going to watch this video, but you are going to solve all the questions that we have over here. Yes, so let's have your pen or paper. Be ready with the questions. Yes, let's look at the question. Do it quickly. All the best. The question says that a stationary wheel starts rotating about its own axis at an angular acceleration, so that alpha is given. It's a 5.5 radian per second square. One more information, it starts, it's an omega naught, it's a 0 radian per second, it is given. It says to acquire an angular velocity omega, which is 420 revolutions per minute. Yes, so 420 revolutions per minute is given. First I need to convert it, so it's a 420, one revolution, it is a 2 pi per minute, it's a 60 seconds. So this is 2 pi by 60. This has gone, and 6 sevens are 42. It's a 7 twos are 14 pi radian per second. Yes, so 420 revolutions per minute, the number of rotations made by the wheel. So what you required, theta or n, number of rotations. So how will you do this? You are having an final angular velocity, you are having an initial angular velocity, you are having an alpha, you required a theta, and from theta you required the n. What I understand is that I will do this, it's an omega square minus omega naught square should be equals to 2 into alpha into theta. Final, it's a 14 pi is required. Initially it was 0, this is 2 into alpha. Alpha was 5.5. It's let's write it down, it's an 11 by 2 into theta. So this is 14 pi into 14 pi, this is equals to 2, 2 that has been gone, and theta, that would be equals to theta into 11. So theta should be equals to 14 pi multiplied by 14 pi divided by 11. This is 196 pi square divided by 11 radian. I hope this is clear. Yes, now what you required number of revolutions. So if theta is rotating, that means if it has made a 2 pi 360 degree, 360 degree, then it is a one revolution, and then it is a one revolution. So n could be given as a theta by 2 pi. So this is 196 pi square divided by 11 into 1 by 2 into pi. This pi, one of the power has been gone, and this is 196 by 2. It's a 98, 2s are 196. Yes, it's a 98 pi divided by 11. This many revolutions is required, this many revolutions are required. I hope this is clear. Did you have the same answer? Did you? Do you have? Yes. Okay, I'm going to add this thing, that find out time required, find out time required to achieve omega. It is the find out time required to achieve final angular velocity omega, that is 14 pi radian per second. I hope this is clear. Great, let's work for the next question. Do it quickly. It says that a circular disc is rotating about its own axis at constant angular acceleration. Okay, now if its angular velocity increases from this to this, that means initially it is 210, it is 210 rpm, so that needs to be converted to radian per second, can be converted by multiplied by 2 pi by 60. Yes, so this is gone, and this is 2 3s are 6 and 3 7s are 21. So this is it's a 7 pi radian per second. Finally, it is 420 multiplied by 2 pi by 60. It's a 67s. So this is 7 2s, which is equals to 14 pi radian per second. Great. Yes, during 21 rotations. So n is given. That is a 21 rotation. Then the angular acceleration of the disk. So if it says 21 rotations, that means its angular displacement is 21 multiplied by 2 pi radian. This is the angular displacement. So what I need to do is that it's an omega square minus of omega naught square, that is equals to 2 alpha theta. The final velocity, it's a 14 pi whole square. The initial velocity, it is a 7 pi whole square. This is equals to 2 into alpha into theta. The theta is 21 twos. Here it is. It's a 21 twos. That is a 42 pi. Yes. So this is 42 twos. It's an 84 pi multiplied by alpha. So just get this done. It's a 14 pi square minus 7 pi whole square divided by 84 pi. This would be your answer. It's a radian per second square, but you are going to solve this. Yes, 14 square 196, 7 square 49, then do the 196 minus of 49 and all that stuff. I hope this is clear. Can it be done? Can it be done by you guys? Are you sure? Are you sure? Can it be done? Great. So let's look at the next question. The next question says that it is the linear and angular velocity of a body in rotatory motions are 3 meter per second. So v is given. That is the linear velocity. V is given, which is equals to 3 meter per second, and angular velocity, which is it's a 6 radian per second. Great. If the linear acceleration, it's an a, which is equals to 6 meter per second square, then the angular acceleration alpha is required. Great. So we understand that v is equals to r omega. V is the 3, r we don't know, omega is 6, that means r is equals to 3 by 6, which is equals to half. Now again, it's an at or tangential acceleration or linear acceleration, that would be equals to r alpha. This is 6, this is 1 by 2 multiplied by alpha. So while doing this, it's alpha is equals to 12 radian per second square. Got it? Done. You did it. Great job. So does this questions can be solved by you? Yes, does it? Are you sure? Are you? Great. Let's work for the next question. You are doing good job. Make it more quickly. Well done. It says a wheel having radius of 10 centimeter is coupled by a belt to another wheel. Okay, so two wheels are there. First is having a radius of 10, another one is having a radius of 30. First wheel increases its angular speed from rest, it's an omega naught equals to 0, at a uniform rate, it's an alpha 1, it's a 1.57 radian per second square. The time, the time for second wheel to reach a rotational speed, final speed of this wheel, it's 100 revolution per minute, so it's a 2 pi. Give me a moment. So this is 2 pi by 60 radian per second. This time is required. Okay, so what what can we do? What can we do in this situation? I hope you understand. Let's look at this. This is the diagram. This is the smaller wheel. For me, it's a first. This is the bigger wheel. For me, it's a second. When these two systems are connected with belt, what I can understood is that r alpha will remain the same. So I can write like this. It's an r1 alpha 1 is equals to r2 alpha 2. One more thing what I can understood is for this, even the velocity 1, I'm talking about the linear velocity, and velocity 2 would be equal. So I even can write it's an r1 omega 1 is equals to r2 omega 2. But here it is an motion with constant angular velocity. I'm going to use this, but if situation requires, even I can write like this. It's an r1 omega 1 is equals to r2 omega 2. So now let's back to the question. It's an r1 alpha 1 is equals to r2 alpha 2. I have been given that initial radius, first radius of the first wheel, it's 10. It's a 10 multiplied by alpha 1, it's a 1.57. This is equals to 30 into alpha 2. From this I can have alpha 2 which is equals to 1.57 divided by 3. Now for the second wheel what I can write, it's omega 2 is equals to omega 1 plus alpha 2 into t. Yes, so as it has started initially from rest, so t is equals to omega 2 by alpha 2. Yes, let's put up the value omega is equals to, let's replace this omega with 2 pi f. Yes, it's a 2 pi n2 by alpha 2. Put up the value and get the answer. It is approximately 20 seconds. Yes, 1000 by 49. Somehow certain more than 20, but approximately it would be at 20 seconds. I hope this is clear. Yes, this is a key point to this question. I must know this. If they have been coupled, then this would be the situation that even this can be written and this can be written. I hope this is clear. Was it was it clear? Can you do this? Are you sure? Great. Let's work for the next question. Yes, very easy question. It says that the angular displacement of a particle is given as theta is equals to t cube plus t square plus t plus 1. Then its angular velocity at t is equals to 2 seconds. Okay, so I can write like this. It's a omega is equals to d by dt of theta, or I should say it's a d theta by dt. While writing this, it is d by dt of t cube plus t square plus t plus 1. So d by dt of t cube, which is equals to 3t square plus 2t plus d by dt of t, it's a 1 at t is equals to 2 seconds. So omega at t equals to 2 seconds. This is equals to 3 into 2 square plus 2 into 2 plus 1. This is 3 fours are 12 plus 2 twos are 4 plus 1. It's a 12 plus 4 16 plus 1. It's a 17 radian per second. That's it. You did this. Great job. I hope this is clear. Is it clear? Is it clear? Great. Let's work for the next question. It says that in the above problem, the angular acceleration of the particle at t is equals to 2 seconds. Okay. So I am having an omega as it is 3t square plus 2t plus 1. Now for alpha, I can have it's a d omega by dt, that is equals to d by dt of omega. That is, it's a d by dt of omega. Omega would be equals to 3t square plus 2t plus 1. D by dt of 3t square. D by dt of 3t square, it is a 6t plus 2. D by dt of 1, it's a 0. So it's at t is equals to 2 seconds. It's a 6 into 2 plus 2. It's a 12 plus 2, 14. It's a 14 radian per second square. What was your answer? Was it same? Was it? Are you sure? Are you sure? Does your answer is the same? Great. So ready for the next question? Are you? Are you ready for the next question? Will you be? Let's have a look to the next question. It says that I is the moment of inertia of a thin circular ring about an axis passing through its center. The same thing is folded into 2 tons of coil. Okay, that has been going to be folded. Now that says the moment of inertia of circular coil about an axis which is perpendicular to the plane of the coil and passing through its center. So how will I do this? What initially what does it say is that the moment of inertia of a thin circular ring about an axis and passing through its center, and then it says that this the same ring is going to be folded into two turns of coil. The moment of inertia of circular coil about an axis which is perpendicular to the plane of the coil and passing through its center. So let's have a look. This is the situation. Initially this was the ring, and its moment of inertia for the ring could be written as it's an I is equals to m into r square. So when I'm going to fold this into a circular coil, when I'm going to fold this into circular coil of a 2 tons of coil, what I understand is that its its mass remains the same. And when I understand that its mass remains the same, that is, I can write like this: it's an I directly proportional to the r square. Yes. One more thing is its radius is going to be half. Its radius is going to be half. So what I can write, it's an I1 by I2, that would be is equals to R1 by R2 whole square. For R1, if it is R square, then for R2 it's an R1 by 2, which is equals to 1 by 2 whole square. That could be written as 4. So I2 this I2 could be written as I by 4. It is as simple as that. I hope you can do this. Yes. What was your answer? Was it same? Was it? Great. Ready for the next question? Almost same question. Let's look at this. It says that a metallic thin wire has a uniform thickness. Okay, great. From this wire, two circular loops of radius r and 2r are made. If if moment of inertia, if moment of inertia of second loop about its natural axis is n times moment of inertia of the first loop about its natural axis, the value of n. Okay, so how will I do this? How could I do this? They have made up a two circular loops of radius r and 2r. Let's look at the diagram. This is the circular loop of radius r, while this is the circular loop of radius 2r. One more thing they say is that I2 is equals to n times of I1, and this all has been made up from a wire, from a metallic wire, let's understood, having mass m and length l. Yes. So what I understand is that the first mass would be equals to, first mass is equals to, that m1 is equals to 2 pi r into m by l. Yes, it's a total mass m divided by total length l multiplied by what you have used. It's a 2 pi r. Yes. The second mass would be, and it could be written as it's in total mass m total length l divided by length that you have used, it's a 4 pi r. So the total length of the wire could be written as 2 pi r plus 4 pi r, that is equals to 6 pi r, because then only this two loops can be made up. And from this I can write it's in radius, it's in l by 6 pi. So now just write it down, the moment of inertia of both. It says that I2 is equals to NI1. So this is equals to M2R2 square. This is equals to M2R2 square is equals to N times of M1R1 square. If I put up the value, it's an M2 which is equals to 4 pi R into M by L multiplied by R2. R2 would be equals to, this is of 2R, so it's a 2 into L by 6 pi whole square. That should be is equals to the length, it's a 2 pi R into M by L multiplied by L by 6 pi whole square into N. If I'm going to solve this N would be equals to 8, and this would be the answer. I hope this is clear. Is it clear? Is it? Are you sure? So can you do this? Can you? Great. Let's work for the next question. It says that it is the 3 point size bodies of mass 10, 20 and 30 gram are attached at the three corners of light equilateral triangular frame. Okay. If their moment of inertia about an axis passing through two lighter particles, okay, lighter one, that means 10 and 20, is 1500, their moment of inertia about an axis passing through two heavier particles. Okay, great. So now what will you do? First have a rough sketch of this, that how I should do this, how I should do this. So what they want is that, let's suppose this is the situation. This is give me a moment. Let's say this is 10, this is 20, and this is 30. Yes. Now they want that if it has been rotated from here, this is I1, they have given this. Yes, it is probably 1500. Yes, it's a 1500 about an axis passing through two lighter particles. This two are the lighter particles. Then the moment of inertia about an axis passing through the heavier particles. So the heavier particles, this would be the heavier particles. This is I2. So now they said that it is an equilateral triangle, and if it is an equilateral triangle, let's understood that this is L, even this is L, and this is L. Yes. So the distance, this distance, let's suppose calculate it, let's call it as a y. Yes. So that distance can be written, let's y should be is equals to root of it's an L square minus of L square by 4, that is equals to root 3 L square by 4, that could be written as root 3 by 2L. This is y. And what I need to do is let's call this as an I2. This I2 could be written as m into y square. So this, for this it's a 30 gram multiplied by y square, it's a 3 by 4 L square. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Yes. So, and this 20 and this 10 was given that it was the I2 was 1500. So from this what I can have, it's a 30, it's a 50. So L square would be equals to 200 divided by 3. Now what I want this, let's call this as an I1. This is the moment of inertia through 20 and 30. This I1 should be written as, this is the 10 multiplied by root 3 by 2 L whole square. So this is equals to 10 multiplied by 3 by 4 L square. I am having a data of L square, that could be given as, it's a 10 into 3 by 4 multiplied by L square. L square it's 200 by 3. This has gone. This is 4 into 50. So this is 50 into 10. It's a 500 kg into meter square. I hope you got this. Yes. Did you get this? Did you? Are you sure? Are you sure? So can it be done? Can it be done by you guys? Are you sure? Great. Ready for the next question? Are you ready? Let's have a look. The question says the mass of a thin circular plate is m and its radius is r. About an axis in the plane of the plate at a particular distance r by 2 from the center of plate. Its moment of inertia is, one second, it says the mass of a thin circular plate is m and its radius is r. If about an axis in the plane of the plate at a perpendicular distance r by 2. Yes, great. So this is something like this. Yes, the mass of a thin circular plate, it's mass m, this is radius r, about an axis in the plane of the plate at a perpendicular distance r by 2 from the center, r by 2 from the center. So this is its center, and let's call it this as an r by 2. from the center of the plate its moment of inertia. So if I need to rotate it from here, this is y dash, this is 1 dash, this is requirement. How will you do this? So what I understand is y dash is equals to, or I should say I dash, it's a I z z by 2. I z z for a circular plate, it's an mr square by 2, and 1 by 2 from this, it's an mr square by 4. So this is I dash. What I required is, it's an I11 dash, it's an I dash plus m into r by 2 whole square. So I dash, it's an mr square by 4 plus m into r square by 4. So this is equals to 2 mr square by 4, which should be given as mr square by 2. This is I11 dash. I hope you got this. Did you? Did you get this? Great. Let's look at this question. It says that the masses of two solid spheres of same material, their density could be the same, are in the ratio of root 2 is to 4. Yes. About an axis passing through the center of the smaller sphere, the moment of inertia is I. The moment of inertia of larger sphere is, okay. So how will you do this? What can be done? What can be done for this? It says that we have given the masses, and we have the masses are given root 2 is to 4, and they said that about an axis passing through the center of smaller sphere, passing through the center of the smaller sphere, the moment of inertia is I. What I need to find out? I need to find out the moment of inertia of larger sphere. So let's have a look. It is simply, it is I1 is equals to m1 r1 square divided by I2 is equals to m2 r2 square. Yes, I have been given that their densities are equal. So I can write like this, it's a density 1 is equals to density 2. A sphere has been given, so density is equals to mass of 1, volume of 1. This is equals to mass of 2 into volume of 2. This could be written as mass of 1 into volume of 1. It's a 4 by 3 pi r1 cube. This is equals to m2 multiplied by 4 by 3 pi into r2 cube. So this 4 by 3 pi and this 4 by 3 pi could be cancelled out, and from this it's an m1 into m2, that is equals to r2 cube divided by r1 cube. I hope this is clear. And from this I can have r1 square is to r2 square. So let's just put up the value. It's a 1 by root 2 whole square. This is root 2 by 4 into 1 by root 2 whole square. So if I solve this, it's a I2 which is equals to 4 multiplied by root 2 times of I. Yes, it's a 4 into root 2 times of I. I hope this is clear. Is it clear? Is it? Are you sure? Can it be done? Can it be? Are you sure? Great. Next question. It says that, look at this. The moment of inertia of a thin square plate of mass 1.2 kg is 0.2 kg meter per square when it is made to rotate about an axis perpendicular to the plane of plate and passing perpendicular to the plane of the plate and passing through the corner of a plate. Okay, great. Something like this. It's a square plate. The moment of inertia of a thin square plate, mass 1.2 kg and moment of inertia. Inertia is given, it's a 0.2 kg meter square. Great. And mass is given, it is 1.2 kg. Yes, when it is made to rotate about an axis perpendicular to the plane of the plate, it could be perpendicular to the plane of plate and passing through one of the corners. So it has been rotated from here and moment of inertia is given. It is something like this. So now if it has been rotated from here, it's an IZZ. So what I can write is that this distance, let's say this distance is y. Yes, what do you need to find out? You need to find out the side length of the plate. How will you do this? How will you do this? How could we do this? So what I understand is that, let's suppose this was the square plate. This length is L, this length is L, this is this is the midpoint. This complete is root 2L, and this half of the distance, let's call it as a y, that would be equals to L by root 2. And you are going to rotate this, you are going to rotate this from here, and the moment of inertia is given. So I understand that this axis and this axis are parallel to each other. So what I can write, it's a, let's call it as a 1 1 dash, let's call it as a z z dash. So it's an I 1 1 dash is equals to I z z dash plus m into y square. Now I z z dash, it's a square plate, it's an ml square by 6 plus m into y square, it's an l square by 2. So that should be is equals to ml square by 6 plus ml square by 2, this is 3 ml square by 6. So ml square plus 3 ml square, it's a 4 ml square by 6, which could be written as 2 by 3 ml square. Now I have been given I11 dash, the data is it's a point 2, and even mass is given. So this is equals to I11, which is equals to 0.2, is equals to 2 by 3 multiplied by mass. Mass is the 1.2, which is 12 by 10 multiplied by L. I hope this is clear. Yes, this 0.2, when I say it's a 0.2, that is, it means it is 2 by 10 only. So if I have written this, it's a 2 2 cancel, it's a 10 10 cancel, it's a 3 4s are. So this could be written as L square is equals to 1 by 4, which converts L to half, and while I say half, it's a point of 5 meter. I hope you got this. Did you? It's a 0.5 meter. Yes. Are you clear? Are you clear with this? Any doubts? Anything? Anything? Are you sure? Great. Let's work for the next question. It says that if I is the moment of inertia of a thin circular plate about an axis passing through the tangent, circular plate passing through a tangent of a plate in its plane, the moment of inertia of same circular plate about an axis passing through an axis perpendicular to its plate and passing through its center. So first, it's a circular plate. This is the circular plate. Yes, a circular plate, let's call this having mass m, radius r, about an axis passing through tangent of plate in its plane. Let's have this, it's a 1 1 dash. Okay, great. And this is what we are calling as I. So first find it out. So this I11 dash and this YY dash are parallel. So for circular plate IYY dash, it's an MR square by 4. It's a IZZ by 2 basically. So I11 dash, that should be is equals to, this is R. It's an MR square plus MR square by 4, which could be written as 5 by 4, which could be written as 5 by 4 MR square, and this has been written as an I. So if required I can write mr square, which is equals to 4 by 5I. This is mr square. I hope this is clear. Now what do you want? The moment of inertia, the moment of inertia of same circular plate, about an axis perpendicular to its plate. What I want? I want this. So that will be IZZ, that should be is equals to mr square by 2, and for mr square I am having 4 by 5I, so this is 4 by 5I multiplied by 1 by 2, so this is equals to 2 by 5I. I hope this is clear. Was it clear? Are you sure? Can you do this? Can it be done? Can it be? Are you sure? Are you? Correct. Let's work for the next question. You are doing good job. Well done. Keep it continue. It says that two point-sized bodies of mass 2 kg and 3 kg are fixed at the two ends of a light rod of length 1 meter. Yes, it says the moment of inertia of the two bodies about an axis which is perpendicular to the length of the rod and passing through the center of mass. Great. So they have indirectly asked two questions. One of the question would be a center of mass, and then we need to rotate it. So let's do it quickly. This was the road. Let's understood this is 2 kg, this is 3 kg, and their length is 1 meter. So let's choose this as a origin. That will easier our task. So the center of mass xcm could be written as this is 0 comma 0. Now this is 1 comma 0, so this equals to 3 into 1 divided by total mass. It's a 3 by 5. So this is the 3 by 5. xcm is the 3 by 5 from the 2 kg. So it is something somewhere here. If it is 3 by 5, if it is 3 by 5 from this, then this would be, it would be a 2 by 5 from this. I hope this is clear. Now what I need to do is I need to something like this is the situation. Rotate this. This is 2 kg. This is 3 kg. This is 3 by 5. This is 2 by 5. And I need to rotate it from here. Let's suppose something like this. So what I need to write is it's an I1 that is equals to m1 x1 square plus m2 x2 square. So for the mass 1 it's a 2 kg multiplied by 3 by 5 whole square plus mass 2 it's a 3 kg multiplied by 3 by 5 whole square. This is equals to 2 multiplied by 9 by 25 plus 3 multiplied by 9 by 25. This is 2 nines are 18 by 25 plus 3 nines are 27 by 25. It's a 27 plus 18. It's a 35 plus 10, 45. Yes, it's a 45 by 25. This is 9 fives are, and this is 5 fives are. I hope this is clear. So this is 9 by 5. This is 9 by 5 kg meter square. I hope this is clear. Is it clear? Is it? Is it clear? Are you sure? Are you sure? Are you sure? Oh, I made a mistake over here. It's 3 into 2 by 5. So this will have an impact on everything. Let's just correct it. It's a 3 into 2 by 5. This is 4 by 25. So this is 3 4s are 12 by 25. This is 18 plus 10 30. So this is 6 5s are. This is 5 5s are. This 2 has gone, and this is 1.2. Yes, this would be the correct answer. 1.2 kg meter square. Have you got this? Have you got this? Are you sure? Are you? Are you sure? Great. Let's work for the next question. It says that three point masses m1, m2 and m3 are placed at the three corners of a light an equilateral triangle of side A. Okay, so this is side A, this is side A, this is A. The moment of inertia of the system about an axis coinciding with the altitude of the triangle, and that is passing through the m1. So if this has been passing through the m1, and this all are the point masses, then what I can write is that moment of inertia due to m1 is 0. Yes, moment of inertia due to m2, which would be equals to m2 into a by 2 whole square, which is a square by 4. Moment of inertia due to m3, it's an m2 into a square by 4. When I make an I total, it would look like this. That's it, you did it. I hope this is clear. This is mastery. Is it clear? Is it? So can you do this kind of questions? Can you? Can you do this kind of question? Are you sure? Are you sure? Shall I add something? So my first question would be, find out moment of inertia when I am going to rotate it from this. Let's call it as an I2. And I want to ask one more question. This is I3. So I'm writing the question over here, that in the previous question, find out I2 and I3 as shown in diagram. So this is the requirement. You need to do this. Please do this. I hope this is clear. Is it? Is it clear? Great. Let's work for this. It says that moment of inertia of a solid sphere about its diameter. It says solid. Yes, about its diameter is I. If that sphere is recast into 8 identical small spheres, then the moment of inertia of a small sphere about its diameter. So, so what I need to understand is, first let's recast this into 8 identical smaller spheres. What I understand is initial volume should be equals to final volume. If I write this, first I am having an one sphere having a radius of capital R. Let's say this, it's a 4 by 3 pi r cube. Then I'm going to convert this into n spheres. Yes, I'm deriving it for the generalized term, so that anytime if you require this, you can use this relation. It's n into 4 by 3 into pi r cube. This 4 by 3 pi, this 4 by 3 pi has been cancelled out. So this r cube is equals to n into small r cube. So this is r is equals to n to the power 1/3 into r. So from this r is equals to, it's an 8, because it has been converted to 8 smaller sphere into r, which should be 2 into r. This is r is equals to 2r. I hope this is clear. Is it clear? Is it clear? Now let's just write it down. Initially it was a single sphere only. It's an I1, which is equals to 2 by 5 mr square, or I should say m into r1 square. Now it would be the I2 would be equals to 2 by 5 into m into r2 square. Let's just have a ratio. It's a I2 divided by I1. This has gone. It's a small of r square divided by capital R square, small r square. So this is equals to r square divided by capital R is equals to 2r. It's a 4r square. This has gone. So I2 is equals to I by 4. That's it. Is it clear? Is it clear? Are you sure? Are you sure? Are you sure? One more thing. Yes, even the mass has been changed. Yes, this should be written as m dash. And while I write m dash, that should be is equals to m by 8. So this is equals to m into r square. This is equals to m dash into r square. This is equals multiplied by m divide by m dash. M dash could be written as, this is the, so I2, okay, I have taken this as an I2. So this could be written as, it's an m dash, which is m by 8 into 1 by m. This 2 has gone. So this is I by 4 into 1 by 8, which should be given as I by 32. Got this? Even mass is going to be changed. So this should be the I by 32. I hope this is clear. Is it? Is it clear? Any doubts? Is there anything? Are you sure? Are you? Great. Let's work for the next question. Yes, there are so many questions. There are so many questions of moment of inertia because it is the topic. It is the topic. It is the place where we require a larger amount of practice. That's why I have covered a most number of the questions of the moment of inertia. Yes, let's do it. This question it says that two rings of the same radius r and mass m are placed such that their center coincides and their planes are perpendicular to each other. The moment of inertia of the system about an axis passing through the common center and perpendicular to the plane of the one of the ring. Yes, if you remember this the same question we have covered in the radius of gyration concept. Yes, to find out the gyration. Let's do it quickly for one more time. It says that two rings are there. This is one of the ring having mass m and radius r, and this is the second ring. This is the second ring. This one is having mass m radius r. This one is having mass m radius r. Yes. Now it says that the moment of inertia of the system about an axis passing through the common center and perpendicular to the plane of the one of the ring. Let's assume that axis of rotation is being passed from here. Yes, this is the first ring and it is perpendicular to the first ring. So what I understood is that for first ring this is the second ring. For I1, as it is a rings, it is a ring, so I1 could be written as m r square. For I2 it is just the y axis, so it's an mr square by 2. So I, it is mr square plus mr square by 2, it's a 3 by 2 mr square. Yes, I hope this is clear. Yes, are you sure? Are you? Great. So let's work for the next question. Now look at this. What does it says? It says that three identical solid spheres, each of mass m and radius r, are fixed at the three corners of a light equilateral triangular frame of side length 3r, such that their centers of the spheres coincides with the corners of the frames. Okay, great. Now they want the moment of inertia of the three spheres about an axis perpendicular to the plane of the frame and passing through the center of mass of the frame. So how will you do this? How will you do this? Let's have a look. That this is the situation given like this, that this is the first sphere, this is the second sphere, this is the third sphere. The sides are having of 3r 3r 3r. What I need to do is I need to rotate it from this passing through the center of mass. Yes, so axis is passing through the spheres, parallel axis passing through the O, and if I want to find it out, the location, it's a cos of 30 degree, that would be is equals to, it's it's a root of 3 by 2 is equals to it's a 3r by a naught, or 3r by 2 a naught, sorry. So from this I am having the data of a naught, which is equals to 3r by root 3. Now let's just find it out the moment of inertia of any one, and I will multiply this with by 3. So for the moment of inertia of any one object, it's I of g plus m into a naught square. It's a perpendicular distance. A naught is taken as the perpendicular distance. So as they have said, it's a solid sphere, it's a 2 by 5 mr square plus m into a naught square. A naught is 3r by root 3, so let's write it, it's a 9r square by 3. If I solve this, it is equals to 51 by 5 mr square. I hope this is clear. Does it does it clear? Any doubts? Is there anything? Any doubts up till now? Is there is there anything? No? Great. So, will you be ready for the next question? Will you be ready? Will you ready for the next question? Are you sure? Are you sure? Great. Let's have a look. It says that it says that two particles of masses m1 and m2 are connected by a rigid massless rod of length r to constitute a dumbbell. The moment of inertia of the dumbbell about an axis perpendicular to the rod and passing through the center of mass. Great. So it is the same question. Previously it has been asked with the data, probably 2 kg and 3 kg, and length was 1 meter. Now they have given with the variables. It's an m1 and m2. The separation of this two is the r. I need to rotate it. I need to rotate it through its center of mass. Let's say this is the center of mass. Yes, so this is the location of center of mass. So let's take this as a origin. So this is 0 comma 0. This is r comma 0. First find out center of mass, which is equals to m2r divided by m1 plus m2. Yes, so let's call it as an x1. This is x1. So what about the x2? What about the x2? So x2 could be written as r minus of x1. So this is r minus m2r divided by m1 plus m2. So this is equals to m1r plus m2r minus of m2r. This is m1r divided by m1 plus m2. This is the x2. I hope this is clear. Now what I need to do is, the situation has been something like this. This was m1, this was m2. This is the axis through which it is going to rotate it. It's an x1 and this is x2. So it's an I, which should be is equals to m1 x1 square plus m2 x2 square. Now just put the value. Now just put the value and get the answer solved. I hope this is clear. Is it clear? Is it is it clear? Are you sure? Are you? Can you do this? Can it be done? Can it be great? So let's just wind up this session over here. This was just the part one. This was just the part one of additional questions of rotational motion. When you tune into the next part, again you will have the additional questions of rotational motion part 2. Yes, I am just taking a hold over here because probably this take a heavier amount of load when you calculate the questions thoroughly for 1 hour or 1 hour 10 minutes. So I am just breaking it. I'm just breaking the session into two segments. Please, before you tune into the next session, again revise this complete topic. As many times we are going to revise it, we will have a good command over it. So please revise it. Please revise it and be ready for the next questions. Thank you. Have a good day. Take care. Bye bye.